We're going to solve another system of equations using matrices. We want to solve this system. 2x plus 2y minus 3z equals 5. X minus y plus 2z equals 8. And 3x plus 5y minus 8z equals negative 2. First thing we want to do is write down our augmented matrix. Remember that the augmented matrix is in two parts. We have our coefficients of our variables, the x coefficients in the first column, y coefficients in the second column, and z coefficients in the third, or a vertical line, and then the coefficients on the right-hand side go in the second part here. Our goal when using matrices is to try to get this matrix into row echelon form. To do that, we need a 1 in this 1, 1 entry up here in this upper left corner. We can do that by switching the first and second rows. So we're going to say our new row 1 is equal to the old row 2, and our new row 2 is equal to the old row 1. If we perform that operation, we get the following matrix. Notice all we're doing is switching the two rows, so our old row 2 becomes our new row 1, and our old row 1 is our new row 2. We didn't change row 3, so we just rewrite that. We go on to another piece of paper. Here we've just rewritten our last matrix to work from there. After we get this 1 in the upper left corner, we'd like to get zeros underneath that. To do that, we're going to make our new row 2 equal negative 2 times row 1 plus row 2. And we want a 0 here so we can change row 3 at the same time. Our new row 3 will equal negative 3 times row 1 plus row 3. If we perform those operations, we get the following matrix. We did not change row 1, so we just rewrite that. To get our new row 2, we perform this operation. Negative 2 times 1 plus 2 is 0. Negative 2 times negative 1 plus 2 is 4. Negative 2 times 2 plus negative 3 is negative 7. And negative 2 times 8 plus 5 is negative 11. To get our new row 3, we perform this operation. Negative 3 times 1 plus 3 is 0. Negative 3 times negative 1 plus 5 is 8. Negative 3 times 2 plus negative 8 is negative 14. And negative 3 times 8 plus negative 2 is negative 26. So now we have 1 with zeros underneath it here. Our next step is to get a 1 along the diagonal in the 2, 2 entry. To do that, we'll multiply row 2 by 1/4. If we perform that operation, we'll get the following matrix. We have not changed row 1 or row 3, so we rewrite those. We're going to multiply row 2 by 1/4. 0 times 1/4 is 0. 4 times 1/4 is 1. Negative 7 times 1/4 is negative 7/4. And negative 11 times 1/4 is negative 11/4. We've got a 1 here. We'd like to get a 0 underneath it. To do that, we have to change row 3. So our new row 3 will equal negative 8 times row 2 plus row 3. If we perform that operation, we get the following matrix. We did not change row 1 or row 2, so we rewrite those. Negative 8 times 0 plus 0 is equal to 0. Negative 8 times 1 plus 8 is equal to 0. Negative 8 times negative 7/4 plus negative 14 gives us 0. Negative 8 times negative 11/4 plus negative 26 is negative 4. Now at this point, we notice that this last row gives us the equation 0 is equal to negative 4. Well, 0 is not equal to negative 4, so this is a false statement or a contradiction, which means that this system has no solution. Or we'd say that the system is inconsistent.